Okay, let's start with this problem. This actually is very easy, but we need to be like very careful on how we solve this because we might get confused with this. Okay, well, we have a mass that's gonna be like here, and it has like 0 kilograms of a mass, and we have two forces. One of them is like doing this. This is gonna be force one. You're asking yourself probably, how do I know it looks like this? Well, both of them are negative, so I'm assuming that it goes like that way. The other one is like negative in x and positive in y, so it's gonna do something like this. So probably my force is gonna do something like this. Okay, the resulting force. Okay, so if the particle is an origin, I need to find a position vector. Okay, if I know the forces, I can know for sure the acceleration. So what I need to do is get the total force. Why is that? Because I know that the total force, net force, is going to be the summatory of all force. Well, no, I screwed that up. Sorry, just wait a second. There. The total force, net force is going to be, well, not this one, this one, the summatory of all the forces, and that's going to be equal time mass times acceleration. You're going to ask yourself, why is that? Well, mainly because I know this thing is going to move. Okay, so from there I can tell that force 1 plus force 2 is going to be equal times to mass times acceleration. Okay, now I'm going to continue like up here. And I'm going to have like minus 2i minus 4j plus minus 2.6 in I plus 5j, and this is going to be equal times to what? 0.4 times an acceleration. Okay, so from there you need to remember that you need to add i's with i's and j's with j's. So I'm just left with just like me to with minus 4.6 I plus j. That's going to be equal to 0.4 a, and we need to solve for a, so I'm going to be left with minus 4.6 I plus 1j. This thing is going to be over 0.4, and that's going to be equal to minus 11.5 I plus 2.5j. Okay, so this is my acceleration. Am I done yet? No, I just got everything in order for me to like compute everything. Let's keep on going. And for part A, I need to find a position vector. Okay, so I know I need this, and I get just an acceleration and some time. So I can start from the fact that this acceleration, this formula, is going to be true for this. That's a half of acceleration times t squared. It's mainly like the one you used in movement in two dimensions, but let's remember that this r is a vector. Okay, so we know that we start from the origin and we start with from rest. So this is going to be 0 and this is going to be 0. Okay, so we're just left with r equals to a half of a is a vector t squared. So from there, I know that this is going to be a half of minus 11.5 I plus 2.5j times t squared, that's 1.6 squared. And this is minus 14.72 I plus 3.2j. And this is in meters, and you're done for the first part. Okay, now let's keep on going for part B. And it's going to be like here. We need to find the velocity at 1.6, so we can start once again from this formula that we should know by heart by now. And this is time plus acceleration times time. And well, I know that the start from rest, so this thing is going to be 0. and I'm just left with velocity. It's equal to acceleration times time, and well, the velocity is going to be equal to minus 11.5 I plus 2.5 J times 1.6, and this is going to be equal to minus 18.4 in I plus minus 4 plus 4, excuse me, in J. Okay, and this is going to be meters over second, and there you go.